All right, this is part two of adding and subtracting rational expressions. So that first part, we focused on finding the LCD. So hopefully you're comfortable with doing that. So now we're going to take a look at how we use that to continue adding and subtracting. Okay, so 6.3, part two, adding, subtracting rational expressions. Okay, so let's go ahead and take a look at this example. Suppose that I have 1 over x plus 2 plus 2 over x minus 1. Okay? All right. So just like with numerical fractions, we need common denominator to add these. Okay, so right now the denominators are not the same. We have x plus 2 and we have x minus 1. Okay, so we first start off by finding the LCD. Okay, so we see that x plus 2 will be there and x minus 1 will be there. Okay, so what we want to do is we want to make our denominators, these two here, we want to make them look like the LCD. Okay, so right now they don't look like the LCD. Okay, so this one is x plus 2, but we want it to look like this. We want it to say x plus 2, x minus 1. Okay, so in order for it to look like the LCD, I'll use blue, I need to multiply it by x plus 2 over itself. Okay, I need to multiply it by 1 in the form of x plus 2 over x plus 2. Okay, and now, oops, not x plus 2. We already have x plus 2. We want it to say x plus 2, x minus 1. So I need an x minus 1 over itself. Okay. So now the denominator looks like this one. Okay. Now we do the next fraction over here. So we have plus 2 over x minus 1. And again, this denominator says x minus 1, but we want it to look like the LCD, which says x plus 2, x minus 1. Okay, so here we need to multiply by x plus 2 over itself. And when we do that, the denominator now looks like the LCD. And now they have common denominators. Okay, so this first part, you find the LCD and you get your denominators to look like the LCD. Once you do that, then you can go ahead and multiply the numerators. Okay, and we're only going to multiply out the numerators, not the denominators. Okay, we're going to go ahead and multiply out the numerators, and then we can combine the like terms in the numerators. Okay, so here we get x minus 1. And over here, distributing this 2, I get 2x plus 4. Okay, over x minus 1, x plus 2. All right, so once we're done multiplying just the numerators, not the denominators, we can go ahead and combine like terms. Okay, so here it's x. Watch your sign here. If this is subtraction, you got to be careful. This is addition. X plus 2x is 3x. Negative 1 plus positive 4 is 3. And again, just keep your denominators factored. Don't multiply them out. Okay, so here's our answer. But now we're going to use our simplifying skills to see if we can simplify this. Okay, so here the numerator has 3 in common. So I'm going to go ahead and factor out a 3. And we have x plus 2 over x minus 1. Oh, nothing cancels. Okay, so nothing cancels, so you could just leave your answer like this. That's fine. Okay, but we'd like to factor it just to see if maybe we can cancel. Okay, if nothing cancels, then you can leave it like this. If your homework online doesn't take this answer, then you might have to multiply out the denominators at this point. Okay, but like I said, don't do it right away because when you get your answer, you're going to go ahead and factor to see if anything cancels. So keep your denominators factored until you know for sure that, oh, this is your final answer. Then you can go ahead and multiply them. And you would only do that if it doesn't take this answer online. Okay, so let's go ahead and recap this. So here are the fractions that you're trying to add. We get the LCD. Okay, we try to make the denominators look like the LCD. So this one says x plus 2. We want it to say x plus 2, x minus 1. So that's what we multiply by. This one only says x minus 1. We wanted to say x plus 2, x minus 1. So that's why we multiply by that. Okay, so get your LCD, make your denominators look like the LCD. Okay, then go ahead and multiply, and combine like terms. And then always check to see if it simplifies. Okay. All right, let's take a look at another example. Okay, let's do this one. Example 2, x plus 1 over x squared minus 2x plus 1 minus, there's that minus, so we're going to have to be extra careful with that when we do our combining like terms. Okay, x minus 4 over x squared minus 1. Okay. All right, we need to factor our denominators. So here it's xx minus minus 1, 1. We have this repeated multiplication, so I'm going to write it as x minus 1 squared. Okay. This one, it's perfect squares, so it's x plus 1, x minus 1. Okay. All right. I'm going to bring it down here so it doesn't get so cluttered. X plus 1 over x minus 1 squared, x minus 4 over x plus 1, x minus 1. Okay, so we factored the denominators. So now we can find our LCD. All right, x minus 1 family, x plus 1 family. Do I see any exponents? I sure do. Right there. Okay, so this is our LCD. So this is what we want our denominators to look like. Okay. All right, so let's take a look at the first one and figure out what we need to multiply it by. All right, so we want our denominators to look like this, x minus 1 squared, x plus 1. This only says x minus 1 squared. So we need to multiply by x plus 1 over itself. Okay, so now this denominator looks like the LCD. Okay. All right. Over here, we have x plus 1. Good. And we have only one x minus 1, but we actually need another one, right? We need another one, and that will give us x minus 1 squared. Okay. And then here, get my x minus 1. Okay, use parentheses to keep everything organized. All right, so now that I have my denominators looking like the LCD, I can go ahead and multiply this out. Okay, so I get x squared plus x, and then plus x, and then plus 1. And then over here, I get x squared minus x minus 4x plus 4. And down here, I'm going to use exponents to represent the x minus 1, x minus 1. Okay. All right, so I multiplied everything out. Let me just double check. X squared, negative x, negative 4x, positive 4. Okay. All right, so now I can go ahead and combine like terms. Now, careful here, because this is subtraction. So this subtraction, you need to make sure it gets distributed. Okay, so watch. X squared minus x squared. They cancel, right? All right, here I have 2x. So 2x minus, and here it's actually negative 5x, right? Okay, so this is 2x and this is negative 5x. So 2x minus negative 5x. 2x minus negative 5x. Okay, here, if you need to write it down, that's positive 2x, and this is negative 5x. 2x minus negative, right? So that becomes positive 5x. So that's 2x plus 5x is 7x. Okay. And then 1 minus negative 4. Okay. So we get that. And x minus 1 squared, x plus 1. That numerator doesn't factor out, so we can just keep it. Okay. So again, factor your denominators. Get your LCD. Make your denominators look like your LCD. Multiply out your numerators and combine like terms. Okay. Again, once you have your denominators looking like your LCD, you just leave them. Okay. Leave them alone. All right. Let's go ahead and take a look at another example. Okay. All right, suppose that we have this, x plus 1 over x squared plus 5x plus 6, subtraction, x minus 3 over x squared minus 4. Okay, so we need to factor our denominators. X times x to make x squared. My signs have to be the same. Both of them are positive. And I will go with 3 and 2, and I get 5x for the middle. Here, it's perfect squares, so x plus 2, x minus 2. All right, so let me bring it down here again so it doesn't get all cluttered. Okay, and subtraction, and I have x minus 3 over x plus 2, x minus 2. All right, so my LCD, what family do I see? I see the x plus 3 family. I see the x plus 2 family. And I see the x minus 2 family. And I don't see any multiplication, any repeated multiplications. I don't see any exponents. So this is it. Okay. So this is it for my LCD. And now I try to make my denominators look like the LCD. Okay. So let's have a look. Okay. This first denominator, x plus 3, x plus 2. we are missing the x minus 2, right? We want our denominator to look like this. So we need to multiply by x minus 2 over itself. Okay, this one, we have x plus 2, x minus 2. We're missing x plus 3, so we need to multiply by x plus 3 over itself. All right, good. Once you have that, all you need to do is multiply and combine like terms. But careful with that subtraction. Okay, so here I get x times x is x squared, and then I'm just going to do this in my head. I'm going to get negative 2x plus 1x. Negative 2x plus 1x is negative 1x. And then 1 times negative 2 is negative 2. Okay. You can write it out the way we did here, where we have all 4 terms, right? X times x is x squared. X times 1 is x. 1 times x is x. 1 times 1 is 1. You can do that. I do this middle part in my head. So that's the outside 1x, inside 1x, giving me 2x. Okay? So that's all I did over here. Outside negative 2x, inside 1x. That gives me negative 1x. Okay, over here, x squared. And then I'm going to do outside positive 3x, inside negative 3x. That's 0. And then negative 9. Okay, and now that I finished multiplying, I can go ahead and combine like terms, but watch your subtraction. X squared minus x squared is 0. All right, and then I only have the negative x, so let's bring that down. And then I have negative 2 minus negative 9. Minus negative 9 is positive 9. So negative 2 plus 9 is 7. And there you have it. This is your answer. Okay. All right. Let's take a look at this one. Let's suppose we have this 3 plus 7 over x minus 15. Okay. So again, if you don't have a fraction, you can always put it over 1. Okay. All right. So LCD is x minus 15. Okay. All right. So we're going to do 3 over 1. We need to multiply by x minus 15 over itself. And 7 over x minus 15, well, that already looks like the LCD, so we're good. So let's go ahead and multiply and combine like terms. So we get 3x minus 45 plus 7 over x minus 15. Combining like terms, I get 3x minus 38 over x minus 15. And nothing will factor and cancel, so I can just leave it like that. Okay? All right, and let's see if you guys remember this, what I said about this sort of situation. Let's have a look. Suppose I have x over x minus y plus y over y minus x. Okay, so remember, these are not exactly the same. If you remember this here, if you ever forget, just do it in your head and put actual numbers and flip them. 5 minus 3, 3 minus 5. 5 minus 3 is 2. 3 minus 5 is negative 2. So remember, these are just opposite each other, okay? So if you want to switch this around, you have to put a negative, right? So you can do this. You can switch them around, but then put a -1. Okay? All right. So now LCD, they actually have common denominators. So we can go ahead and combine like terms. So we get x minus y from the numerator, and then we get x minus y here. And that actually cancels. So this equals 1. Okay? All right. And let's just go ahead and put both operations together the way we did with multiplication and division. So let's suppose we have this. So we'll have 3 fractions here. That's our first one. X squared minus 3x plus 2. And this one's our third one. X squared plus x minus 2. Okay, so let's go ahead and factor all of our denominators. Here, I'll do it in blue. Actually, let's do it in purple. Okay. X plus 2, x minus 2. Perfect squares, right? And then this one, x times x, both signs the same, 2 and 1. Okay. This one, x times x, opposite signs, 2 and 1. Where to put the 2? Here. Okay. All right, so let's take a look. What is our LCD going to be? Our LCD. I see an x plus 2. I see an x minus 2. I see an x minus 1. Okay. And I think that's everybody. No exponents. So no exponents in our denominator. So no exponents in our LCD. Okay. I don't see any repeated multiplications. Okay. All right. So let's go ahead and figure out what we need to multiply each one by. All right. So this first one, 2x. We have x plus 2, x minus 2. So what do we need? X plus 2, x minus 2. We need the x minus 1. Okay. So we need to multiply that by x minus 1. Okay. Very good. All right. Bring down that subtraction sign. 1 over x minus 2, x minus 1. What are we missing? We have this one. We have that one. We need that one. We need x plus 2. Okay. So we need to multiply by x plus 2 over x plus 2. Good. And let's do the third one. We have x plus 1. We have x plus 2, x minus 1. And we are missing, let's see, we have x plus 2, we have x minus 1. We're missing x minus 2. All right, very good. So now all of the denominators look like the LCD. Okay, so now we can go ahead and multiply out and combine like terms. Okay, let's see what we get here. 2x squared minus 2x. I'm just going to write them all over the same denominator. Okay, and then over here, never mind. Okay, we have a lot of factors in this one. All right, minus, and that's just going to be an x plus 2. Okay. All right, and then this one, multiplying that out, x times x is x squared, and then negative 2x plus 1x is negative x, and then negative 2. Okay, this is going to be our last example, so go through the work. All right, so let's go ahead and combine like terms. 2x squared plus x squared. 2x squared plus x squared is 3x squared. Okay, so I got those out of the way. All right, negative 2x minus, so careful with that minus, negative 2x minus x is negative 3x. Negative 2x minus x is negative 3x plus negative 1x is negative 4x. Okay, so we got rid of those. Now, careful again, right here, this subtraction still needs to get distributed over there. So that's actually a negative 2. This is one of the biggest mistakes that students make. They don't distribute the subtraction to everything here. Okay, so that's a negative 2 plus a negative 2, which is a negative 4. Okay, and x plus 2, x minus 2, x minus 1. And then we want to factor this out to see if anything cancels down here. So we may or may not be done. Okay, so let's see. 3x times x. Signs have to be different. You can try 2. 2 and 2. Let's check. Outside is negative 6 plus 2. Negative 6 plus 2 is negative 4. That's what we want. And then x plus 2, x minus 2, x minus 1. Aha! Thank goodness. Okay, here, x minus 2 cancels with x minus 2. So we can see here that this is, that's the answer we got, but we can simplify that answer. Okay, so that's why it's important to, number one, leave your denominator in factored form and make sure once you get your answer that you factor your numerator to see if anything cancels like it does here. Okay, so the final answer is actually 3x plus 2 over x plus 2, x minus 1. Okay, so that is it for 6.3, adding and subtracting. Okay, don't forget to message me if you have any questions.